Hello and welcome to this short DBmarlin video, where today we will take a look at how you can get to the root cause of database performance problems very quickly. To start with, let's head over to the database instances screen. This is our top-level overview across all the database instances that we're monitoring. Here you can see that we can sort by things like the average SQL execution time, by the number of executions, or by the total amount of time spent executing SQL. In this case, our top database is the Postgres 11 instance. Next, let's click here to drill down a little bit further. Here on the instance level dashboard we can see the total amount of time and number of executions again. We can also see how they vary over time. Here is a case where the database resource consumption was very high, and then we can see something changed, and the resource consumption suddenly dropped very low. One of the things you'll spot straight away is that DBmarlin tracks changes and overlays them onto the timeline, as you can see here. The time dropped when a change occurred, and the time in the database suddenly shot back up when more changes occurred. Already, we're very close to the root cause of the issue, but just to show you a few other things that you can do within DBmarlin, let's look at the wait states. Wait states are very important when you're tuning a database. They tell you where the time spent when those SQL statements are executing. In this case, we're looking at a Postgres database, and we can see things like buffer mapping, data file read and buffer I/O, and we can see how much time spent in each of these different wait states. From a tuning point of view, we need to minimize the amount of time spent waiting as much as possible. Next, let's show the host metrics and see how the CPU and memory utilization are looking. We can see that the database host is running at 100% CPU, and that drops down after the index is added. We can also see where the time spent across the SQL statements that are running. We have 4 statements, which account for something like 95% of the total database time, and then everything else accounts for the other 5%. If you scroll down a little bit further, we can see it here in tabular form as well. We see the 4 top statements, which account for most of our time, and then everything else further down the list, which is less interesting from a performance point of view. If we click into this top statement and look at the performance profile, and toggle on the wait states again, we can see that this statement's profile is similar to what we saw at the instance level. Scrolling down a little bit further, we can get all the way down into the very root cause of this issue. Here we've got the SQL text, and if we go to our Changes tab, we can see the indexes that were created and dropped, and the timestamps of when that happened. Within DBmarlin, the types of events that will get picked up automatically are things like schema changes or parameter changes, but you can also register your own change events using our API and linking it to your CI or CD tools. Here we can see 2 code releases with links back to the deployment details. In this case, we can see the 2 indexes that have been dropped, which have obviously had an adverse impact on our performance. If we go to the Execution Plans tab, we can see what the impact was. Here we can see the execution plan, which is what the database optimizer determines is the best way in which to execute the SQL statement. During the time frame we're looking at, we've got 2 different execution plans as identified by the little number here. We had one which had a relatively low cost of around 20,000, and then one with a much higher cost of around 303,000. If we have a look at the low-cost plan first of all, we see that for the where clause within our SQL statement, the optimizer has decided it can use an index scan. And that's what makes this step quite efficient. If you compare that to the much more expensive plan, for the same where clause, because there's no index available, it has to do a sequential scan on the rides table, which is a very large table. This means it has to scan every single row within the table, which is much less efficient. So hopefully this video has been useful, and you can see how, with just a very small number of clicks, we can get to the root cause of database performance problems using DBmarlin. Also, the importance of being able to see change events overlaid onto the timeline, so we can relate changes back to their performance impact. Thank you for listening, and subscribe if you like this video, and look out for more videos coming very soon.